Alrighty. What is going on, everybody? Welcome to Learn to Defend Cyber. My name is Joseph. We're going to be working on TryHackMe's Advent of Cyber Day 24. Today is the final day. So if you've stuck with it and you're here and you're looking for the walkthrough, congratulations. I know it was pretty hard to keep up with. Life is busy, and this is 24 days. Some people did it once a day. Some people did it a couple times a week. Maybe you did everything on the weekend and you just did 7 days at a time. But here's the finish line. So let's go ahead and cross it. I didn't see if there's a machine for today yet. I don't honestly know. Yeah, there's a machine, so I'll go ahead and get it stuck up. We'll get it spun up real quick. It does seem like we have a longer one today. So we'll wait for this machine to spin up for a moment. And I will get a little more comfortable because it does seem like it's a little bit of a longer one today. We can go ahead and start reading actually while this spins up because it does have quite a bit of text. Okay. Pivot over. I can hide the chat box for now. Alright. In Wareville, the townspeople started to frown. A problem with smart lights all over the town. Was Sockmas ruined? The chances were 0. Because this, they knew the glitch was their hero. Wareville invested in smart lights and heating, ventilation, air conditioning, HVAC. It was easy to control the lights and heating remotely. Following the recent incidents, McSkitty started monitoring these devices, communication protocols. Not long after the lights and heating were up, malware figured out how these devices were controlled and sabotaged them. We're going to talk about the MQTT protocol. We're going to use Wireshark to analyze MQTT traffic, and we're going to reverse engineer a simple network protocol. Okay. I have not done much of anything with the MQTT protocol, so this will be a first time for me as well. Oh boy. Make sure this is alright over here. Alright, looks fine to me. Alright, now that this is spun up, we can go ahead and hit view screen, or view in full screen with these tiny little arrows over here. Hit the exit split view. Go ahead and allow it to see anything on your clipboard that'll help us copy and paste commands. Okay. So, smart devices make lives very easy. We can just control everything from a phone or a panel or a tablet or whatever that may be. With smart HVAC systems, we can maintain the temperature of our homes and ensure they're not too cold or hot when we come home from outside. Smart vacs clean the house while we go out for dinner or shop or do whatever else. And as I said, we can control them from our mobile devices. Even better, since they can be controlled remotely through apps, we can make designs more minimalistic and aesthetically independent, and the need for adding switches or controls on the device itself is minimized. Alright. So, smart devices connected. We like to call them Internet of Things, IoT. From a security point of view, anyone can technically interact with these devices so long as they are able to connect to the panel or whatever application controls these devices. Okay. We can limit the exposure of these devices by adding things such as network isolation, authentication mechanisms, and if we fail to do so, it can be catastrophic. I tend to advocate for having IoT on its own network that can't really communicate out anywhere outside of the internet, really. The most secure system is a system that is shut down, so there's always a way to take advantage of how these things function. Alright. we should lean into smart devices is what they're saying, but we need to make sure we're following best practices. The language of IoT. All right. Although different IoT and smart devices use different programming languages depending on the model and vendor, they need to speak the same language to be able to communicate with each other. So IoT devices might use C++ or Java to talk to the compiler and the underlying hardware, but they still may use HTTP or MQTT to talk with your system or mobile device. So MQTT stands for Message Querying Telemetry Transport. Very common in IoT devices for communication purposes. It works on the publish-subscribe model, where any client can publish messages, and client devices can subscribe to the messages if they are related to a topic of interest. An MQTT broker connects the different clients, publishing and subscribing the messages, and we have a nice little graphic here. Okay. Let's see. So we might have a thermometer that says, hey, publish the value 30 for temperature to the broker. And the moisture is 65 degrees. And your car is seeing that you're accelerating a certain, I guess, amount. I don't know what the G stands for. I would assume grams? I don't know. It's weird. Either way. MQTT clients are the IoT devices such as sensors, controllers. They publish or subscribe messages to the MQTT protocol. For example, a temperature sensor can be a client that publishes temperature sensors at different places. An HVAC controller can act as a client that subscribes to messages from the temperature sensor and turns the HVAC system on or off depending on the input received. The broker receives messages from publishing clients and distributes them to subscribed clients, and the topics are usually used to classify the different types of messages. So you might have topic like temperature, light readings, etc., you know, moisture level. Really depends on the device, apparently. Learning about a protocol theoretically can be confusing. Let's see how it works in practice. Files related to this task are in the desktop MQTT SIM directory. So they give us, we land on the desktop. Here's our folder right here. This is where everything is. We have a walkthrough folder and a challenge folder. As we discussed, different IoT devices communicate with each other using the MQTT protocol. So we're going to monitor network communication to see what is going on. We will use Wireshark to monitor the communication on the left side. We can see Wireshark right here. Sorry, y'all. I mean, yawn like that. Alright. So we're going to use Wireshark, which we used a couple days before. We've used it a couple times throughout this challenge. Right. It's just a packet capture tool. We can monitor our network. So we're going to go ahead and use the any network interface. So if we're here in Wireshark, come on. We can full screen it. Oh, it looks like I opened a couple of them. Alright. We can go down to the any interface right here. Go ahead and double click it, and you'll see that we are receiving traffic. I don't know why we're like... Alright. You can see the number of packets. This little red box right here will stop capturing the packets, so it'll stop moving. You see what time it is, from the IP address to what IP address, what protocol it's going over, the length of the call, and the information about the different packets. Alright. So what we can do is use the filters. Since we are only looking for MQTT, we can go to this top bar right here and specify MQTT. It'll go green if it's right. It'll go pink if it's wrong. All right, we hit enter and there's no traffic because we don't have anything running with that protocol. There's a shortcut on the desktop named LearnToMQTT. This directory has different scripts. All right, we're going to go ahead and open up this. Go to the walkthrough. Let's run walkthrough.sh. We might need to bring up a terminal. So we'll bring up a terminal. I'll use Control-Shift+ to blow it up. All right, we can CD to our desktop. All right, we can CD to MQTT-SIM. Go ahead and CD to walkthrough. And we can do a /walkthrough.sh. So we ran the script. Once we run it, 3 windows will pop up. The window with the red text is the broker. The window with the blue text is the client. And the third is the application UI we may see as the end user. We can look at the logs of each of these windows if we like, but as an end user, we will only interact with the application UI. UI standing for user interface, by the way. So we can see that we have the client here. We have the broker. Right, this might be a little bit interesting to try and keep up with. And then we have our actual user interface here. What's going on, Brandon Maverick? Happy holidays, man. Alright. So what are we going to do? The application is in automatic mode. The heater is off. The target temperature is 22 degrees. I assume Celsius because it's probably going to be pretty cold in Fahrenheit. Current temperature is 22.3. Let's head over to Wireshark to see what kind of communication we can see. Alright, we still have Wireshark open. You can go over to the side panel here, and we do have communication here. Alright, you can see we have a connect command. We have the acknowledge. It looks like they're subscribing to some information here, and they're publishing messages. We can probably click on one and see what they're doing. Alright. So they're pointing out how the communication is started with that connect and the connect acknowledge. If I don't see any traffic, close all windows, restart your steps. First 2 events will show the connection establishment. The next 2 events show that one of the clients wants to subscribe to the home temperature topic, shown in the square brackets. We saw that. Then it acknowledges that subscription. The events from home temperature topics are from the temperature sensor, and the events from the home heater are published by the HVAC controller. So it looks like anything from this temperature one is from our actual thermostat, and this is from the heating and ventilation. In the lower pane, we can see that is publishing a temperature of -9.68 and a bunch of numbers. That is very cold. Therefore, we see a message from the heater right after the temperature is broadcast saying that it was turned on. So it says that it's 22, 22, 22, 21, 2. I want to see where it's that -9 degrees, because that is very, very cold. Probably all the way, honestly. Yeah, we got 3 degrees here, which is still pretty cold. And then it says home heater on. So that's that traffic we're seeing right there. And then it starts to slowly raise the temperature. Honestly, pretty quick. It's going from like 3 degrees to at temp within 10 seconds. That's a pretty crazy heater. All right. This is showing our communication stream here. It's saying, hey, publish temperature 22 degrees. It subscribes to the temperature, and then it says that it turned back off. So if once the temperature sensor sees that we hit that desired temperature that we have set, it's gonna go, hey, this is what temp it is. It goes, oh, I see that that's the temp you want. I'm turning back off now. All right, we can use Control-C on the window with red text, which seemingly will turn everything off for us. Right? Maybe. Let's close out these other windows. So let's go to challenge.sh. So we can use cd ... and that will take us up a directory. And you can see we're back in that we're back in the MQT sim directory. I'm gonna go ahead and cd to challenge list. Looks like we already have a pre-generated challenge PCAP. We can run the script challenge. It will open the 3 windows for the light controller interface. So we will go ahead and do /lights.py. Oh, sorry. Challenge.sh. Alright, and it's going to bring up something similar to what we saw earlier. The lights are off right now. So, however, nothing works and we can't turn anything back on. So, yeah, this isn't working. I'm not seeing any kind of feedback. Our little app go. Come back. There you are. Alright. Make sure we have that pulled up. And in Wireshark, we should be able to see this new communication. They connect, they subscribe, they acknowledge the subscription, then it looks like they subscribe to something new. Looks like it's base 64 encoded, oddly. Then we have 2 acknowledges, and then they're trying to ping back and forth. Okay. So what are we gonna do? Now that we have basic knowledge of the MQTT protocol, we must find the command to turn the lights back on. The challenge.pcap file is inside the challenge directory. This contains a packet capture containing various MQTT protocol messages relating to turning the lights on and off. So we're going to start another Wireshark instance. We can just click on it over here on the right. Alright, and we can go to File, Open. And we can open this challenge.pcap.ng. And this is a pre-canned packet capture for us to work through. Okay. Let us... I just accidentally sorted something. That's fine. Let us specify that we are looking for MQTT, just like we did before. And this will filter us down to all of our MQTT traffic. Alright, we see the connection. We see 3 subscriptions from 1, 2, and 3. They are publishing message for all of this nonsense. ID 1 subscribes to this, publishes a message. ID 2 subscribes. ID 3 subscribes, then they publish messages. And that seems to be the end of the communication. Alright. Is this one going to be over in a flash like yesterday? Are you going to be continuing labs, etc., moving forward considering AOC is ending? Yes, I am. I'm going to be... my plan is to just, like, every Monday, Every Monday at 5 p.m., I should be streaming and doing labs from Try Hack Me or Hack the Box or Let's Defend, because I got permission from them to stream, so that was pretty cool. So, should be Mondays at 5. The AOC thing was kind of impromptu. I'd been trying to scrounge together some stuff to start streaming. I was trying to hold off until I had a better PC, but I was honestly just going to keep making excuses for not buying a new PC, considering how expensive they are. So I'm just rocking with what I got. Okay. So that is the plan moving forward. Now that we have basic knowledge, we can open the PCAP. We plan to publish a message to the MQTT broker in order to turn on the lights. As a result, all of the lighting devices subscribed to this MQTT broker will turn their lights on. We can achieve this from the command line using the mosquito pub command. Consider the following example: mosquito pub h localhost t topic m message. So localhost refers to the MQTT broker, which is localhost in this task because we're running it off of the 127.01 address, which is that local host. That's our loopback address. T specifies the topic. M specifies the message, such as on and off. To determine the correct topic and message to turn the lights on, we are going to have to look at the captured packets, and once we figured it out, ensure we are running challenge SH, and use the mosquito pub to publish a message to turn the lights on. So a flag will appear on the lights controller if we did it right. So let's look. Let's look at our messages here. We can see that we are publishing a message to this saying off. So theoretically, we should be able to just do the opposite and say on, right? I don't know what this value is, 13 to 2. Alright, so we're gonna specify our topic. Kind of going back through, because they do just cut us loose. I want to go through and see if there's any kind of hints back here, right? Topics, light readings, maybe, right? Light readings might be it. So what do we subscribe to when we subscribed? Publish message. D2, bunch of nonsense. Theoretically, I should be able to just copy this, right? Can I copy this? Control-Shift-C maybe? What happens if I... Remember, our red one is this broker, right? Did that copy? Not seemingly. I want to copy this string. Let's copy the value, and I paste it in. Not seemingly so. So let's just try. I mean, they gave us a value earlier. Let's see if that's it. There is that topic they gave us, light readings. That sounds like it's more worried about light levels. Mosquito pub. Let's try light status, maybe? You know, hey, you never know. Message. And we want to just say on. Did we get anything from our active? No? Anything from our light controller? No. Did we see anything on our active request when I did that? Publish request. So it is something to do with this. Maybe this is just base 64. Copy bytes as a hex dump. Maybe we may need to get Cyber Chef involved in here. So from hex dump, paste this in here. That did not work. Copy. I don't know what as printable text means. Ooh, that ain't it. Well, hold on. That is, though. So what if we do from base 64? Oh, we got something. Wareville. That's right. We're onto it. We're onto it somewhere. I think it's the slashes messing it up now. So let us backtrack. Wareville. Christmas lights. Yeah, we got it. On time equals 1800. So that was our request earlier. So what if we go into that already captured one, right? We published a message down here that told it to go off somewhere. This was the challenge PCAP. Alright, we have some base 64 here. We can copy this out. We will copy the value. Alright, we see Wareville. Christmas lights. So it's just Christmas lights on, I assume. Let's try. Let's go back through here. We can see the messages published by different clients with their topics in the square brackets. So, what if I do mosquito pub slash or tac T Wareville Christmas lights with the message on. Oh. It would help if I typed pub. Mosquito pub T Wareville. I think it's a it's a / Wareville Christmas lights. I also didn't type Christmas lights correctly with the message on. So now theoretically no. What happened in our Wireshark instance? Did it do anything? No, we didn't get any new traffic. Do we have to copy it exactly as it's shown here? Maybe decoding it from base 64 wasn't correct? If that's the case, I will copy this value. Copy value. We'll go back here and we'll do mosquito pub with T. I don't know why it's not letting me paste. I really don't want to type that value out. Message such as on and off. To determine the correct topping message to turn on, you must study the captured package. Ensure you are running challenge SH and use the mosquito pub to publish a message to turn the lights on. The pub is the red one, right? Am I just typing it in the wrong spot? Red text is the broker. Blue text is the client. So, do I need to be typing this just in a shell? Am I even typing localhost? Oh, dude, I'm not. Oh, no. Yeah, that might be an interesting issue. Christmas lights with the message on. Did that do anything? No, we might just need to do this from a shell, like an actual just shell. Did that do anything? No. So let's just try opening up a new terminal. I want a new one, please. Thank you. Because we need 50 bajillion terminals. Alright. Mosquito pub. Oh, I got caps locks on. Pub. -H. Local host. Because we are running on that. With the value Wareville. Christmas lights with the message on. Command mosquito not found. Oh, probably because... Am I spelling mosquito wrong? I am. And there's also an underscore. I'm doing everything wrong. Oops. Oh, we got traffic. That happened. Did this do anything? Let's see if we can bring up that light controller and see if we did it. Does not appear so. So maybe it is, we have to do it with the base 64 encoded value instead? Do I still have that oh god. Do I still have... No, I'm gonna have to go grab it from the PCAP really quick. Disconnect request. Publish message. Okay, so yeah. It definitely wants us to have that base 64 value then. Alright, so let's copy this. Copy the value. We will go into our terminal. This is the wrong terminal, but we'll go into a terminal. It's down here. And we will rerun our command. But instead of the decoded value that I went and got, we will paste this and just, I saw it pop up in the blue. Blue is usually good, and they're on. So we got it. Okay. I guess I was overthinking it a little bit then. That is our flag that I can't copy for some reason. That sucks, so I'll have to type that in. A little bit of overthinking there, but it is a blind walkthrough, so LIGH75. Doing a little bit of leet speak. Dash day saved. Oops. Day. Right, it was with a 4. No, it was just an A. 5-4. VED. Close the curly bracket and hit submit. And we got it. If you liked that, look at the Wireshark topic. Let's go ahead and finish it out. We got a nice little comic. The mayor's about to claim victory. We can probably kill this. And kill that. Alright. I'm not going to read out this this comic for you. It is here for you to read. Mayor Malware tries to claim victory. They're like, hey, he's evil. And then Glitch was called the hero. And we can hit that. It says, congrats for saving Sockmas. What did it say down there? Something about a blue fur dot? Yeah, a dot of blue fur. You can see him running away. And then it wants us to take a survey. So I'll go ahead and take that survey on my own time. Let's pivot over to the other scene here. That was a good time. I really enjoyed that. I want to thank y'all for sticking through with me and hanging out and having a good time with Try Hack Me's Advent of Cyber 2024. I think it went well. I mean, there were a couple rooms throughout the event that felt a little maybe like they didn't have enough context in there. I remember getting upset on one of the on a couple days, but I wasn't like upset. I was just more like, oh, this could have been a little bit better. But I think honestly, it was still good, even on the days that were a little frustrating. Some of them were long. Some of the days felt super short, like 5-10 minutes. And I think that's fine. I don't think all of them have to be long at all. I think that consistency in the amount of time it takes is fine. I thought all the walkthroughs provided by the trainers went well. So I'm really looking forward to Try Hack Me's Advent of Cyber 2025, and I'm looking forward to working through the year to bring some more content to y'all and, you know, level up the stream little by little. So thank you guys so much. Thank you all so much for tuning in. I hope you enjoyed the content. Make sure to like and subscribe. I will be live Mondays at 5 p.m. Eastern Standard Time, bringing you more training content, more walkthroughs. I'm sure it's going to be a hell of a lot more chaotic than this, because they're a lot less handholdy on their normal walkthrough rooms. So I look forward to it, and I hope you all have a happy holidays, whatever you celebrate, wherever you may be. And I'll see y'all next time. Thank you.